So you gotta go.
So good afternoon to all. Thanks for coming for this tutorial. So I thought, uh, so I'll be talking basically about TensorFlow mostly, and also about how you can, and also Keras, which is an abstraction that is above TensorFlow. So, but before that, I want to talk a little bit about deep learning because that's what TensorFlow is all about. So, have you familiar with deep learning and machine learning? So, okay, so but I'm sure all of you must have heard about artificial intelligence, right? I mean, if you open the tech news today, you will always be hearing this. And deep learning, the simplest way to put it is like the hottest way to do AI right now, to write AI programs right now. And so if you have, and if you look at it more deeply, so you have artificial intelligence and you have a bunch of techniques under that. And machine learning is one of those techniques. And within machine learning, you have what is called deep learning. And now deep learning is so powerful that literally everybody equates deep learning with artificial intelligence. So, uh, what is machine learning? So usually we write programs. When we write a program, we have to the programmer as a programmer. We have to write every step of the way. Like we, so we have to instruct to the computer to do a particular task. But so in machine learning, what we do is rather than telling the machine to do, instructing the machine with every single step, what we are doing is we are showing examples to the machine. So, for example, suppose if we have a bunch of images about the Simpsons family, and you want to recognize the individual members of the Simpsons family. So what we do is, so in machine learning, what we do is we take an image of, let's say, Homer, and we give it to the machine learning model, and then we also tell the model that okay, this is Homer, and then we go through a process called training, where we have a model that adjusts itself to recognize Homer to like so when we give another picture of Homer, the model will actually predict with some probability that this is Homer. And so this is the basic. So it's not just with images. You can do it with literally any type of data set. You can do it with simple numerical data sets. For example, you can predict you can give a bunch of weather variables and predict what is the temperature tomorrow. What the model does it learns all of this from the data. We are not writing any rules. We are not telling like what is the color of Homer's face or how Homer's eyes look. The machine is actually learning it from by itself during the training process. So we can use the same model that we use for this image recognition for any other kind of data set. So the model and the training algorithm doesn't change. It's pretty much similar for everything. And so this is machine learning, and deep learning is a subclass of a technique under machine learning. And what exactly is deep learning? Well, the simplest way to put it is it's a really big neural network. And so neural networks are nothing but very simple abstractions of the neurons in our brain. So at the simplest level, it's essentially a matrix multiplication and addition, and followed by a nonlinear transformation. So you have a bunch, and you are using a large number of these neurons in the neural network, and that is what and training a data set using the neural network as the model, and that is what deep learning is all about. So I mean, the basic concepts are actually very simple, and they have been around for like more than 50 years now. So I'll just. So if you look at the timeline, actually the artificial neuron that was invented way back in 1957 by some of the pioneers in AI. But and there have been a few developments during the first 50 years, but really nobody really cared about it, like because they found that it's very hard to train a neural network. So there was very limited application of this. But then what happened was that in 2012, somebody came up with a model, a neural network model that could, do this image recognition really much better than any other existing machine learning techniques. So the current that this craze in AI actually started in 22, and then it's been a very, you could say, exponential growth. You have many big developments, and you have nearly all the top tech companies like Google, Microsoft, Amazon, Apple. Everybody is into this. I mean, this is their and most of the apps that you use in Google, it's probably it's done using deep learning, and it's probably made using TensorFlow. And very recently, the most recent development was the AlphaGo Zero. That was it was uh, a it was a program that could play the game of Go, which and it can beat literally any human player. So what happened during this past 5 years? So literally nothing has changed with the algorithm. You are using the same neural networks, except that you're having much bigger networks. So, but the main thing that happened was that you have a lot of training data available in the form of digital data. So, and that's what really made the big difference, because to train neural networks, you need a much larger amount of data compared to what you need with a normal machine learning model. And then, of course, there's the computing resources. And all this is actually possible only because you have GPUs. Because this is neural networks are very parallel computing structures. So you need to have you need to have a lot of processors which are capable of doing very simple calculations. The underlying calculations are simple, but there are a lot of them. So this is very easily parallelizable, and so GPUs can do that much better. Yeah, and then there are some improvements in the algorithms, and of course, then there is open source libraries like TensorFlow. So these libraries, they bring all these together, like the computing, the algorithms, and the data. You can use these libraries to bring all these three together to build your machine learning models. So and TensorFlow is just one of the library, but there is actually literally every company has one library now. Like for example, Facebook has PyTorch, while Microsoft has CNTK, and then then there are a few others and Theano was actually developed by one of the universities, and and TensorFlow is of course by Google. But right now, TensorFlow is probably the most widely used library. But even all the other libraries are also good, and PyTorch is the newest library. So why use TensorFlow? Well, TensorFlow was first released just about 2 years ago. That was in 2015, and from then it had actually had a lot of changes, a lot of updates over the years. Like literally every month you have an update. So now we are running at TensorFlow 1.3. That was the most recent one, and there is a lot of advantages. The one thing is a lot of companies are actually standardizing using TensorFlow. So many of the companies are using that. And then of course it's open source, and it's very actively being supported by Google. So if you are developing something with TensorFlow, you don't have to worry about it going out of running into you're going to get support for a long time. So essentially. And then so I started learning TensorFlow actually only in like just 1 year away now with 28. That was when the Windows support was actually released. Before that, it was only available on Linux. So and there are many other advantages. One is that you can run it on literally the same code that you write on TensorFlow. You can run it on the cloud or on your PC, or even on your you can write programs for your Android app using that, and also you can write programs for your your embedded devices, like for example Raspberry Pi. And then also it's very easy to like switch between the CPU and the GPU. Like you don't need like the same code can be run on the GPU. And this was not possible before, because you need to have for CPU. I mean for GPU you need to write separate code, but this is not a problem with TensorFlow. You just write the same code, and you can actually select which device you can run on. And of course, there is also distributed computing. You can write the code and you can distribute it across multiple computers, and that is also not very difficult. Okay, so if so this is a TensorFlow architecture. So you have the underlying the TensorFlow. So you have a front end that you get with Python, and also with some other languages. But Python is the one that is supported by officially supported by Google. So under this this front end you have the what's called TensorFlow distributed execution engine, which is completely written in C, and that is what is. So when you're writing the code in Python, it actually compiles it in this execution engine, and then gives it to your CPU or whatever device you have underneath. And so we don't really need to bother about what goes underneath. So we'll be writing applications using the front end, and there are many abstractions above the front end. For example, you can write there are things called API and data sets, and also you have the Keras model on top of that. So that's where Keras. So Keras is not a new program. It's something that is already inside TensorFlow. So it's just an abstraction about TensorFlow. So it's actually easier to write programs using Keras compared to using core TensorFlow. Okay. So it's not straightforward to write a program in TensorFlow because it's different from how you normally write the program. So what we first do is we have to first define something called the computational graph, and then the computational graph is your model or the architecture that you're using. And it can be either a neural network or any other kind of machine learning model. But most of the functions are useful for neural network models. So first we build the model there. Then once we have the model, we take it and put it into something called a session, and we execute this graph. And executing is the graph. The graph is where we train the model, or we can use that model to do some prediction or something. So you have two clearly defined separate things that you have to do. And that is if you are using core TensorFlow. But if you're using, Keras, there is not the separation is not so stark. You can do it using you don't need to create a separate session. Okay, so what is a computational graph? So as I mentioned earlier, it's just a way of defining a model architecture. And I have an example here. And you create this TensorFlow here, this computational graph using mathematical operations like matrix multiplication, and also you have what's called weights, biases, and also you have to also give placeholders on the TensorFlow graph to tell the model like this is where the data is going to enter from, and this is where the data is going to leave from. So this is where we build the model, and there are a number of methods that you can use to build this graph. So there's a lot of flexibility that is available. So one, we can use the core operations like the simple matrix multiplication and all. So you have to individually tell the model that what you have to do in each layer, and then but this is good for learning the model and if you want to build a customized model. But if you want to just get into it, you can use what's called the layers abstraction, which is so you get one layer by itself, and you can just use that. And then if you want even better abstraction, you can use the Keras API, which is even more faster. And yeah, for beginners, I would suggest if you want to do, it's best to start with Keras because it's much easier to get into. Okay, so you have a lot of core operations like and also some advanced operations that you can use. Yeah, but the most important operation that you have to use, which is called optimizer operation. So that is where we do the training. That's the last one that I have given here. So So, and this is what really makes having a library, a deep learning library, better compared to writing your own program. Because training a neural network, it's very it uses a process called backpropagation, where you have to actually find the gradients in each layer of your model. The gradients means the normal, so it's essentially calculus, but you have to do that for each layer of the model, and this is not a simple thing to do. But using TensorFlow, you have something called optimizers, where you can just specify which optimizer and you are using, and the model and TensorFlow will do the rest of the things for you. Okay. And there are, so I also mentioned that you have to use data is very important for building a deep learning model or a machine learning model. So there are different methods to have to feed the data into the model. So one is called the feeding, is the simplest method. But the thing is that you need to know that all the data should be loaded into your Python environment. Models, this is okay, but suppose if you have like a large number of images, which is having like 1 terabyte of data, you cannot load that into your RAM. And so for that, and that's where that usually occurs in the production environment. So there, what you have is you can use something called the queues, which actually so you just need to have the data stored on the disk, and this queue will fetch the data during this training or inference. But this queue is actually a very complex queue. So what they did that, they actually introduced a new API called Dataset API, which was recently introduced, and this it's an alternative to both queues and feeding, and but it is much simpler to do to use that. So yeah, in this demonstration, I'll be just showing the feeding part. Okay. So I'll be doing two codes. So one I'll be using a simple TensorFlow core operations, and so I'll be trying to predict the earthquake magnitude given some information, and then the second one I'll do is using the Keras. So what I'll be doing is I'll be taking a bunch of images from Simpson, and I'll be asking the model to identify different members of the family. So so I have the images, and you know that images are nothing but numbers arranged in a 2D array. And that's what I'll be doing. So you have the image as an array of pixels, and then I'll be so also we need to give the label to the data that we are giving. So, but obviously the computer won't understand what is Homer and what is Marge, but the computer understands labels in the form of your giving us a one hot label. So you have a vector which and where like corresponding to each of the label. So finally, you get a batch of image arrays and one hot labels. So this is a couple of image arrays and one hot that you can get. And then I'll be so I've given this on my GitHub repository if you're interested to look at the model. So yeah, for this particular thing, I'll be using what's called the convolutional neural network. So the earlier I had shown a model of the simple feed forward network, which is the simplest model. So convolutional network is a somewhat more complex neural network, but essentially the neurons are the same, but there is slight difference in how they process the data that is coming. So convolutional networks are the ones that is being always used in the image recognition. So I'm using that. So essentially, I'll be giving an image to the network, and it will be giving probabilities for that tell which class it belongs to. So in this case, I have like 5 classes. So going to the program now. Okay, so I have my program in my the Jupyter notebook, which is another environment for IDE. You might be familiar with it. Uh, so 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 to import TensorFlow, what I'll be doing is I'll be using this. This is a statement that you use to import TensorFlow, and you have to install TensorFlow separately into your computer. And for that, so it comes as a Python package, so you can just use pip install TensorFlow and it will do the installation. But it needs a lot. There are a lot of dependencies for that, but it will also install all the dependencies. So when you want TensorFlow into the in your program, you just use this statement and you import it. And and I'm also importing some other things I need. So what I'm defining some folders basically this tells where I'm storing my image data. So I'll show that actually. Okay. So I have a lot of so I have so in this folder I have a lot of images of for the 5 different classes that I'm training to, and each of them contains nearly the same image. So uh, yeah, so I'm just pointing to where this images are, and I also have another folder that contains that's called a validation folder. So when you're training the model, you want to make sure that the model actually works for images that the model never saw. So if it only works for the images that it actually saw, it doesn't. It's not going to work when you actually put it into a production environment. So that's why we have a set of. That's why we have something called a validation data. And so we'll actually be looking at how the model is during the training process. We'll be looking at how the model is performing for the validation data, not actually what it's doing to the training data. So then we get an idea of how well the model is going to do when you actually put it outside. So I have a few functions for importing the data to the necessary arrays. Yeah. Okay. And some functions for displaying and everything. Okay. So I have like nearly equal number of images for all the classes that I have. And then except for one, this one for unfortunately I don't have a good enough, and uh, that will be reflected in the results that we get actually. So the model actually won't be able to recognize this particular class. So okay, and similarly I have a number of pictures for the validation data set, which is this one. Okay, and then okay, so then uh, I told earlier that if you so this is actually a lot of images, so nearly like 5,000 images, and if I were to load all these images into my my PC would crash. So what I'm doing is I'm using a Python generator. You might be familiar with generators. So, but I won't be rather using creating my own generator. I'll be using one what's called this particular generator from Keras. So this is available within Keras. So what it does is it does exactly the same as a Python generator. So it takes uh, um, some data and store during the training process. It takes some of the data and stores it in memory, and when the training is over, it again takes another set of data. So we are able to specify how like how much amount of data it is being used. So in this case, I am only taking 8 images at a time, and also because if I take more than that, I will I'll get bottlenecked in the memory. And similarly, I have a generator for the validation data set. So yeah, okay. So this is the generator. This is our input pipeline, our data input pipeline, and now we have the what do you say the where we develop our model. So what we are doing here is that we we have we are saying that we are having a sequential model, and that's what this statement is doing. So see, so when we give this command, Keras knows that we are going to build a sequential model, and then we just need to add whatever we need to this particular model. So as I told earlier, neural network is nothing but a large collection of layers of neurons. So what we are doing here is that we are adding layers. Like first we are adding one convolution layer, then we are adding something called the max pooling layer, and then so we are just keeping on adding layers, and finally we add what's called the dense layer, and the output. That's for doing the final prediction. And also you have, there are some other things which is not connected to it. So you have something called the resizing layer. So because you need to so these images are of different sizes, so you have to to resize the model so that it will all the images are uniform. So you have that area to do that, and also you have something to normalize the image data, because the images are usually stored as an integer value, so 0 to 255. So, but if you give it like that to the neural network, the neural network won't train properly, because the network prefers values between 0 and 1. Normalizing it using that by just dividing it by 255. Okay. So what we did here is we defined the model, and so if we, and using this command we can see how the model looks like. So this is the model that we just defined. So it has like three convolution layers and two feed forward layers, and finally an output layer. And the output layer has five outputs, which is so it's going to give a probability for each of the classes. And then also you also have to tell the model like how are you going to train the model, and that's what being done here in this statement. So it's called the compiling the model. So we are telling the model to use the an optimizer called the Adam optimizer, and also we are telling the kind of loss function that we are going to use in the model. So we did all that, and then so now so we have the model now. So if you're going to run the model, so I have to run this model. Yeah. So before I train the model, I can check how the model is doing, like what is the accuracy that, because now since you have an untrained model, the model is going to just randomly pick one class. So, and that's what, so if you do the training before that, so if you try to check the accuracy of the model before training, we'll see how the accuracy is. So sometimes it takes seems to run into some errors. It's very strange. Okay, okay. Let's just train the model like that. What we got. So we defined the model. We defined one pipeline to input the data in the model, and now so to train the model, what we are going to use is this particular command called the fit generator, model.fit generator. So and here we are going to specify that generator that we defined earlier, and also we are going to tell the model that how many iterations is it going to train. That is given by this one. And also we are going to give the validation data set. We have defined a separate set of validation data that's given here. And also finally we are going to the model that we are going to get, we are going to save it in as Simpsons model.h5. Okay, let's just run this and hopefully it will run. Okay, so now the model is training, and training the model takes quite a long time. Like but the thing is that you need to like if you don't have enough computation resources, it's going to take hours and hours to train if you train at all. And normally you need to train for like more than 100 iterations to actually get the required accuracy. So obviously you cannot do that. So if you look at this, so this model arrived at this loss with an accuracy of 0.06, so that is basically 6% accuracy, and this is a training accuracy, and you have, and on the validation data set you have like 5.8% accuracy, and this is the training loss. So obviously we cannot use this kind of accuracy. So the only way to do it is, you have to train this for many iterations. So I had trained this model earlier, so I'll just, so to load a model that you trained earlier, you can use this function. So I'll be loading that. So so I trained on, I could get around 81% accuracy. So that's what you see here. And now let's see what it, so I'll be taking one image, randomly picking one image from the validation data set, and I'll be predicting its output. Yeah, so for example, this one, it got wrong. So so this is the actual image, and this is the probability that the model is giving to each. So it's telling that it seems, so in this case this got wrong. This should be marked, but it's Lisa somehow. So we can try another one. Yeah, and again this is also wrong, because, so if you remember, the Maggie one was only had like around 100 images in the training data set, so it would always get this wrong, but the other ones, it usually get it correct. Yeah, so for example, this one, it got the BART one very correctly, and then so we can try it out. Yeah, but this one, it thinks this is Mars because of the, probably because of the blue hair. So the idea is, you have to so 80% accuracy is not enough. You need to for an image classification model, you need to train the model until you get around 95% accuracy, and that's when, and when it gets 95% accuracy, it usually works very well with models that images it has never seen. And the only way to do that is, of course, to train it, keep on training, and also you have to tweak the model. So you have a model that, so this is just, I randomly made this model. I didn't really follow any procedure. So what you can actually do is you can add more layers to the model. You can add more convolutional layers and you can change parameters within the model, like the number of filters within each convolutional layer. So I mean, there is a lot to talk about the parameters within the CNN that you can change. I mean, that's like another whole lecture on its own. But so yeah, so this is one way to do it, and so this is using Keras. So now, as I mentioned earlier, you can do the same using TensorFlow, but you'll see that it's much harder to do it using TensorFlow. So I'll open up that program also. Okay. Yeah. So before I start, so do you have any doubts, like any questions that you want to ask? Like, I've been, I don't want to this to be a just me talking. If you have.
Adding the amount of layers to the model increases its accuracy.
If you have enough training data, okay, you can. If you make the model large enough, you can make your training accuracy very high. You can get 100% training accuracy, because the model will does it actually remembers every image that you show into it, or every data that you show into the model. But the thing is that it's just doing remembering. It's not able to generalize. But so your validation data accuracy might be very low in that case. So you have to actually so like if you have like 5,000 parameters in your model, like in this model I think it had around 5,500. So generally you need to have at least more than that number of training examples. So in this case we had like I think total around probably 6,000 image data. So it can do it, but the more training data it has, the more better it can do with the validation. It can actually perform in a real world environment, because that's what all this is. I mean, uh, if the model works very good in training, but it doesn't gives very garbage values in the when you actually put it in a real environment, then it defeats its purpose. So you have to actually strike a balance between how big your model is, or how many layers it has, and how much data set you have. Okay, so in the so this is for an earthquake, predicting the magnitude of an earthquake. So that's our thing. So it's the same. So we are importing TensorFlow as earlier. And so we have. So I have, and I'll be importing some data here using. So you have this. So essentially, this data set has some three features: latitude, longitude, and depth, and you're trying to predict the magnitude. So here you have quite a lot of training examples. So you also as earlier, you need to normalize this data, because all this is in different scales. So if you give it to during the training, the model is going to not going to perform accurately. So that's why you are using the normalized data function too, and then that's one of the advantages of TensorFlow, because and this is just one of the ways you can normalize the data in using TensorFlow. There is a lot of inbuilt functions that you can use to do this. So you don't really need to write anything on your own, because most of the time what you want to do, they already have it in the data. Already they have implemented it. Okay, so again, so earlier, you are specifying some training parameters, like how many epochs you are training and everything, and also something called the learning rate. This basically learning rate tells you like how fast your model converges. Yeah. So here, so this is where the making a model in TensorFlow is different from how you do it in Keras. So here, first you have to define your placeholders, like where the placeholders for your input and your output. So X is my input. So I'm specifying that I have an input that has X features, that is 3 features, and this is for the amount of the number of samples. So this is given none, because this can vary. And similarly, you have an output that consists of like 1 feature. And so after that, you can define your model. So I'm defining the model just using the core operations in TensorFlow. So essentially, you are defining the variables in the model. So tf.variable is nothing but you are defining a number of parameters for the model, but these parameters can change during the training process. So you're defining that here in the form of weights and biases, and then you're doing the matrix multiplication. So this operation is equivalent to one neuron, one layer. But so if you go back to the Keras one, we did all this using just one statement. This one statement did all that. But here we are writing all these all these statements. So this is good for learning TensorFlow, but if you want to make a really big model, this is not a feasible way to do it. And so similarly so this is a very simple model consisting of just one layer and one output layer. And finally, you are also calculating some metrics, the mean absolute error. So you have to do it on. So earlier when we were using Keras, we didn't have to write a specific command for this. This was all we had to do was like we had to specify the metrics, and we didn't the Keras would do the rest for you. But when we are using core TensorFlow, we have to specify each and every thing that we want the model to do. And similarly, we are giving a loss function, the mean square loss function, and also we are going to specify the train step. So we have to essentially write these 4 steps where we could do it with just one step in Keras. And then so this is the computational graph that we built. And then next we have we had to start a training session to train this model, and that's what is being done here. So we have to make some operation for initializing the model with some random variables, and then we so the training session is being done using this command called the so we are calling a session, and then we are running this session, and then what we are doing is we are passing in that operation that we defined earlier for the training. This is operation that we defined, and we are passing it through this to the run command, and also we are also going to give the training data set. So here, which is what we are making here. So 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 these two commands, this whole command we did using just one statement in Keras. So this whole one command took care of all these things that we are doing here. So but the advantage of TensorFlow is that you can customize like what you want to see, like and what you want to do. There is a lot more customization that is available when you're using just core TensorFlow. So if you run this, yeah. So now I'm just running the model, and that's going to take some time. Yeah. So this is so it's going to run that. Oh, there's one more thing that I want to show you, which is an important feature of TensorFlow. Yeah, so there's one feature in TensorFlow called the tensor board. So you are building this model, and this. Oh dear. That usually doesn't happen. I guess I have to restart. So this is why I hate using TensorFlow on laptops. The best way to do it is go to the cloud and get a good machine. Good. I guess it's restarting. Okay. Okay, I'll show you tensor board. Hopefully that won't crash. So there's one feature in TensorFlow called tensor board, where what you do is so that when you're running TensorFlow, the session in TensorFlow, or you're training the model in Keras, so it's behind the hood. It's actually logging all the things that you're doing. That the losses and how the weights are changing. It's doing. I mean, it's actually logging all these things, and you can actually see that. Oh, I think I know why my.
Is it a debugging tool?
Yeah, it's a kind of a debugging tool, but more like a visualization inside of what is going on inside the model. So I think I understand why it was crashing. My power was low. So for that, you have to go to command line. Yeah. So and then, so when I ran the model, what happened was that I have. So if you go here, so I have actually some logging that was going on in the background, and that is what you see here. Like, so this thing actually this log contains a lot of the what happened during the training procedure. So I only need one log, so TensorFlow can only read one at a time. So I'll just delete the other one. So you can, using the command line, you can launch TensorFlow. Yeah. Okay. So essentially, it opens up in port 606. So you just need to go to that port. Okay. Oh. Oh. Okay. So this is so essentially you have a lot of variables that you are logging, like the loss, the categorical accuracy, and so for each epoch. So in this case, I only had one epoch. That's why it's only showing one value. So if you have like 100 epochs, the graph for the 100 epochs. So how the accuracy, the loss, how it changed during this 100 epochs, and you can also see do as it as a war time. So when you are having a single model, this really is not that useful. But usually what happens is that you are actually going to test out multiple models. You are going to, because I told you can change the parameters of that model and see which gives you the best accuracy or the best or the minimum losses. So you will have a bunch of models that you can keep in a queue and you can keep on running. This TensorFlow board can actually plot different graphs for each of this model, and so when you come back, you can see what happened. And similarly, you can see how the weights of the model, how the weights are changing. And so this is and also the graph that we made. So, and also we get a visualization of what happened in the graph. Like, so we defined a graph earlier. So this is that graph that we defined earlier. Like, so we have the different layers, and you can even go inside and see. So this is useful for debugging, because when we write the code, maybe we'll make a slight mistake somewhere, but we can actually go back and see what like, did the model turn up the way we wanted it to turn up. So you can go inside and see how the if the different operations are. And finally, you have the distributions. Okay, the distributions. So you are also okay. So you have basically here you have the histogram of all the how the values in your the parameters in the model are distributed. So, and this is just for one iteration. So if you have multiple iterations, you will actually see a 3D graph which shows how how the weights are evolving. Yeah. So this is basically it. Yeah. So yeah. So this is a very good debugging tool, and the other libraries actually don't have this. This is one of the biggest advantages of TensorFlow, because this tensor board. Yeah. So any questions? So did you find it useful for your thing?
Yeah. So the TensorFlow is just one of the deep learning libraries.
Yeah, it's just one.
So is there any other ones that is TensorFlow the easiest to use, or is there any easier ones than TensorFlow?
TensorFlow, all the libraries are hard, but one thing is that it has the most documentation. TensorFlow has comparatively the most documentation that you can use. And also, another thing is, then if you don't want to use TensorFlow, you can just use Keras. That's fine. And the Keras has even better documentation, because Keras was actually, it was there before TensorFlow. So earlier, Keras was built on top of another library called Theana. So, but when TensorFlow came along, so what they did was Google took and Keras was built by one independent guy, that one developer. So Google liked it so much that they literally took Keras and put it inside code and so forth. So the easiest way I would say to get, I mean, if you want to do deep learning, is probably using Keras compared to that, because TensorFlow does have quite a steep. I mean, I've been learning this for 1 year and I just know like maybe 10 or 10% of it.
Yeah, it seemed like the Keras code was a little simpler.
Yeah, it's much simpler to develop, and it's also used in the industry. Yeah, it's, much simpler to use. Yeah. So, no other questions? Yeah, sure.
Why did they choose? So you said that TensorFlow is back to Python, right? Or less than that, like.
The front end is Python.
Yeah.
So
Why do they use Python instead of like other languages? Is there a reason why they use Python more than like C++?
If I had to guess, it would be because Python has like a bunch of scientific libraries like NumPy.
Yeah, exactly. That's a
and other languages. They don't have as great of a scientific support.
This TensorFlow is actually very tightly integrated with NumPy library. Because when you feed data to the TensorFlow, it actually needs to be in, like you cannot feed lists or dictionaries, but you need to actually feed it as NumPy arrays. So that is one good reason. But they actually do support other. I mean, they don't officially support it, but they have support for C++ and Go and all. Yeah, and another reason is probably I think Python is probably the best one for data science. Right? Python and R, so that must be another reason. Okay, so hope you found it useful. Anyway, thank you for listening to the lecture. Thank you.